What?
Do you want some gum?
Okay, so let's run through this real fast. Excuse me.
Want us to write this?
Okay, so basically this flow chart details how many roots there are. It doesn't tell you what the answers are, but it will tell you how many answers there are. So again, if we look at our general form, which is that a is equal to some root of b, we're focusing on the index. What is the number outside the radical sign? So again, we have two choices on our menu. The first choice is that the end value is odd. If the end value is odd, well, it's very simple. That means we have one answer. Could be a positive number, it could be a negative number, but there is going to be an answer. And here's two examples. If I have the cube root of 125, that's 5. If I have the cube root of negative 125, that's negative 5. So it doesn't matter whether the radicand is positive or negative. We are going to have an answer. On the other hand, if my index is even, then we have to go to a secondary level of questioning, and that is, what is the radicand? What is the value of the number under the radical sign? Is it positive or is it negative? If it's negative, that means we don't have any real roots. We have roots. We do know what the square root of negative 9 is, do we? Square root of negative 9 is 3i. But since I stands for imaginary, imaginary obviously is not real. Even those of you who think your imaginary friends are real.
Okay, he was.
They're not.
He was.
Right said Fred was not real. It was Phoebe Case's imaginary friend. Anyway, 3i means that it's an imaginary root. It's a root, but it's an imaginary root. So for our purposes, no real roots. And then, of course, if the value under the radical sign is positive, that means we're actually going to have two answers. One negative, one positive. So the square root of 25 is plus or minus 5. Two roots, plus 5 minus 5. And remember, that positive value, we refer to that as the principal root. Okay? So this flow chart will be helpful in helping you determine whether I have real roots. Because you're going to see questions where you're going to be asked to find the roots, find the real roots, and you need to know that your answer is going to be no real roots. You don't have to waste your time working on that problem. Okay, does anybody have any questions? Is there anybody not done copying? Okay. Let's talk briefly about this. All right, just a couple of things I need you to consider, and that is, of course, if my index is even and my value under the radical sign is negative, that means we have how many real roots? None. Over here, if you have a now, notice the difference. Now I have a negative number, but I'm raising it to a power. Once I raise this number to a power, negative 2 to the second power is 4. The square root of 4 is 2.
You can.
Thank you.
Like the 15.
Yes. So guess this way. You don't have to write it down. It's only if you feel you need to write it down. If you know this already, then fine. Don't write it down. That's true for anything that we do in here. If you already know it, there's no reason to write it down.
To help it get from your head.
That's up to you. So again, even though it's starting out as a negative number, because we are raising it to another power, and then once we raise it to a power, it's going to become a positive number, that means we are going to have an answer. So don't just assume every time I see a negative number under the radical sign, I have no real root.
Which one do you copy?
Okay, the cube root of negative 27 is negative 3. The fourth root of negative 81 is
No roots.
not no roots.
No
No
real roots.
real roots. Remember, it's only when the index is even and the value is negative that it's no real root. Okay, the square root of negative 7 squared, 7. And the square root of negative 49, no real roots. Who said 7? Square root of 49 is 7, not the square root of negative 49. Okay, does anybody have any questions?
How'd you get number 1?
I plugged it into my calculator. Actually, I just happen to know the cube root of 27 is 3. And that the cube root of negative 3 times negative 3 times negative 3 gives me negative 27.
That's awesome.
My suggestion is just use your calculator.
So we just have to put the root.
Basically, yeah, but you have to recognize sometimes there's no real root. In fact, the calculator told you as much. It told you that there are it says no real calculations. Well, that means no real roots. Yes, Miriam. That's right, because if there's no n here, that means it's the square root. Don't lose sight of that. It's still a square root. It's just that we change it if there's a number. If there's no number, it's just square root. You don't lose, that's been the way since you were in grade school. Don't forget that part. That hasn't changed. Okay. All right. Okay. Now, we're going to change things up a bit. And now, what you're going to see is not only a number in the index, but you're going to see exponents underneath the radical sign. For now, the only way that we're going to be able to do these problems is when the number under the radical sign matches the index. Later in the chapter, you're going to learn how to solve these when the numbers don't match. But for now, the numbers have to match. So we're going to have two different possible scenarios. Scenario number 1 is that the number under the radical sign, the exponents are odd. So in other words, if I have this, the cube root of 3 to the 3rd power, okay? If I have this situation, if I have where these values are odd, what that means is that my answer is simply the number under the radical sign. Because the way we solve this is we divide. We take the exponent inside the radical sign and we divide it by the index. So what happens when I get 3 divided by 3? You get 1. Well, 3 to the 1st power is 3. So when the numbers match, they cancel out, and your answer is simply the number that was underneath the radical sign.
But it's absolute value, so it's going to be constant.
No. When it's odd, the answer is just the number.
So when it's even, it's absolute.
When it's even, so as we have here, now I have 4s, which are even numbers, last time I checked. So 2 to the 4th power is 16. The 4th root of 16 is 2. But again, we can divide these out. Now, if I have an even root, what is the 4th root of 16? It's plus or minus 2. Because negative 2 to the 4th power is also 16. So I get plus or minus 2. So, but I don't want a negative number as my answer. I only want positive values. So to eliminate the possibility of writing down a negative number, I use the absolute value symbol.
What's an absolute value?
Distance from 0.
Alright.
So if you think about distance, distance is always positive. So again, these numbers are odd, we don't have to worry about absolute value. We just go about our business and solve the problem. When these numbers are even, we're going to use the absolute value symbol. Okay? Yes?
What does it say?
The answer is the absolute value. It's an absolute value of A if n is even. So it's just A, it's just the number if the n is odd, it's the absolute value if n is even. Okay? Now, that's not true all the time. Now, not true all the time. Even if this is an even number, we don't always use absolute value. And I'm going to show you.
Wait, don't they have to be the same numbers in the box and outside of the box? in
Yes,
order
but
to-
all your problems are going to be like that.
Okay.
Okay, so here's the problem we're going to solve now. We want the square root of x to the 8th, of 16x to the 8th power. Okay? Now, by way of starting out, we're going to show you the long way, but there is also a shortcut, and the shortcut is good for those of you who have a good understanding of dealing with exponents. So, first I want to ask you, let me
Wait, but x to the 8th isn't the same as the second.
I understand that. I'm going to get to that.
Okay.
Hold that question. Okay. By the time I'm done, if I haven't answered your question, then you raise your hand again. Okay. Let's take a quick trip down memory lane and go back over how to deal with exponents. So if I am multiplying two numbers together that have exponents, what do I do to the exponents? You add them. So x to the second power times x to the third power is x to the fifth power. But if I take a number, an exponent, and I raise it to another power, what is x to the second taken to the third power? It's x to the sixth. So when I am raising something to another power, I multiply the exponents. Okay, now if I have x to the sixth, and I divide that by x to the third, what you subtract the exponents. Now, these two are two sides of the same coin. This is multiplication. This is division. This is addition of the exponents. This is subtraction of the exponents. So if I want the opposite of this,
Wait, 6 divided by 3.
when you're dealing with exponents, you subtract the
Oh,
exponents.
subtract, okay.
The opposite of this is this. The opposite of raising something to a power is taking its root. So, if we multiply when we're raising to a power, what do you think we're going to do when we're taking the root? You're going to divide the exponents. Now this is easy. What's the square root of 16? 4. To get the x, we're going to divide 8 by 2. 8 divided by 2 is 4. 4x to the 4th. you're asking yourself, well, how come there's no absolute value? This is an even number. Mr. Spessner just said, when this is an even number, I use absolute value, but he didn't write absolute value. What's going on here?
Oh, just kidding, I missed that. Your hand doesn't.
Does anybody think they know the answer? Okay, Jillian.
When you use an exponent, you can't use absolute value.
No. Good guess.
Well, they're not.
What
Well,
do you divide?
they're not the same. The 2 and the 8 are not
Oh.
the same number.
No, but I could show you how to turn them into the same number,
Oh.
but I think it's easier to just understand that you're dividing. To me, that seems simpler. Raise your hand. No. Good guess. Okay, the answer is, you ask yourself a question. You ask yourself, are there any values of x that I could plug in here that will give me a negative answer? In other words, obviously, if I plug a positive value in, any positive number raised to a power is going to give me a positive number. But if I take a negative number and I raise it to the 4th power, what kind of number am I going to get? I'm going to get a positive number. So since there's no way for me to get a negative answer here, I don't need the absolute value. Okay, again, since there's no way for me to get a negative answer, I don't need the absolute value. The only time I need absolute value is if my answer could be negative. Yes, sir.
So the 4 would be a 3.
Not if this 4.
Yeah,
That's right.
there's only one 4.
Oh, here's a 4.
Oh, true.
That's right. So the shortcut way to look at it is, if the exponent in your answer is odd, you need absolute value. If the exponent in your answer is even, you don't need absolute value. Okay, let me show you another problem.
Oh, that was a scary one.
Wait, I'm so confused on how you got that.
Okay, so this one, I want the 4th root of this. So, how do we find x? Divide. So I get x to the what? I get x squared. Y to the 12th divided by 4. I get y to the 3rd. And Josue
Wow.
will have finished the problem for me. We just talked about it.
Yeah, we did. You're right.
What finishes the problem here?
Division. Roll call.
What do I need? Ask yourself a question. Can I get a negative answer?
Yes.
Can I get a negative answer for x?
No.
No. Can I get a negative answer for y?
Yes.
So if I can get a negative answer, what do I need to put in? Absolute value.
Is it because it's the odd number?
Yes.
Oh.
Did you already do the first step?
Yes.
No, I skipped it. I went straight to the answer because it's easier.
It's 4 divided by 4.
It's 8 divided by 4 and 12 divided by 4. I'm trying to make this as uncomplicated as possible. That complicates things. Easier way to do this is just divide. Divide 8 by 4. Divide 12 by 4. Trust me on this. I can show you, you can look at the book. This is how the book does it.
No, I believe it. I'm just confused. You keep crossing things out.
Yeah, that's what I'm saying. Like, I just wrote the first point and then you crossed it out.
Oh, because, like I said,